Okay, students. Now, in the last class, we have discussed parallelogram law. Before I move to our next topic, resolution of vectors, let us first discuss one very important application of parallelogram law. I remind you, in case of the parallelogram law, two vectors are acting here, A vector and B vector, along the two adjacent sides of a parallelogram. Its resultant C vector will be given by, its magnitude will be given by C is equal to root A square plus 2AB cos theta plus B square. This is the formula. Right? What happens? Suppose this is the figure. What is this figure? Look, this figure shows a, it's a sling. हिंदी में जिसको गुलेल कहते हैं. It's a sling. उस स्लिंग में क्या होता है? There are two arms in the sling. Normally it is made up of wooden. These are made of wooden or bamboo. And the two arms here V-shaped, in which the two rubber strings are attached in this way. Actually, one rubber string is attached with both. Both the ends of the rubber strings are attached to this. And what happens? A stone is kept in between. It is pulled. When it is pulled, according to Newton's third law, you are stretching it in this direction, but its reaction force will be acting in the opposite direction. Alright, as shown in the figure, A vector and B vector. And when you release it, the stone will be moving with the resultant C vector. It's a very good example. It is a very good example of the law parallelogram of vectors or law parallelogram of forces, because forces are the vector quantities. Force is a vector quantity. So it's a very good example of the parallelogram law. I told you before also, parallelogram law is one of the most important laws, so it is a very important to discuss. Okay. Now, let us move to here resolution of vectors. A very important topic it is. That is we are discussing the resolution of vectors. Resolution. Let us say this is a xy plane. Look, xy plane in two dimensions. This is the xy plane. What happens? There is a vector A vector that is specified in this plane by magnitude and direction. It is shown by this line OP. Okay, A vector. What happens? What is resolution? What I do? From the tip of this vector, I drop a perpendicular. M is the here foot of the perpendicular and N is here the foot of the perpendicular. M and N are feet of perpendiculars. Then what happens? OM and ON are known as the resolved parts of A vector. Two parts, OM and ON. These are called the resolved parts. And how they are named? This is named as AX. This is as AY. ये जो है इतने वाले को, इतने पोर्शन को मैं कहूँगा AX और इस पोर्शन को मैं कहूँगा AY. समझ गए? इनको कहते हैं X component and Y component. X component of A vector, Y component of A vector. Look at it. It is the X component of A vector. This is the Y component of A vector. X and AY are the two resolved parts. Now, what happens if now look, I want to change AX and AY. Obviously, they have only the magnitude. They are the scalar quantities. If I want to convert it into vector quantity, then what we have to do? We have to multiply these scalars with unit vector in that direction. And I hope, dear students, I hope you remember that I cap and j cap are the unit vectors along x-axis and y-axis. This is why I will write so OM vector will be equal to Ax into I cap and ON vector is equal to ay into j cap, and on vector, if I say on vector is this, which is equal to mp vector also, this is equal to mp vector, and this is on vector. Look, if I make them vector, these are scalars. If we convert them into vectors, they must be multiplied with the unit vectors in the respective directions. Along the respective directions, we have multiplied them with the unit vector in the respective directions, like this. I hope all of you are agreed to this. No problem. Then what will happen? I hope now this is not required. I am removing it. Not required now. This we have removed. Now what I do? Let us apply by triangle law. Triangle law of vector addition. Let us use triangle law of vector addition. What will happen? Obviously, OP vector must be equal to OM vector plus MP vector. OM vector plus MP vector, that must be equal to OP vector. All of you are familiar with the triangle law. So how much it is? A vector is equal to AXI plus AYJ. Alright. Moreover, this is the vectorial representation. If I want to find out its magnitude, how much it will be? A vector magnitude, or A should be equal to root AX square plus AY square. Okay. Now, very clear? In right angle triangle, I take the right angle triangle OPM. Let us take the right angle triangle OPM. How much we are getting? Can I write OM is equal to A sin theta, and MP is equal to OM is equal to A cos theta, and this is A sin theta. Look, OM by A is equal to cos theta, simple trigonometry. So no problem, it is a simple trigonometry. So what we can say from here, on dividing, what we can say? We can say this is A sin theta by A cos theta is equal to A sin theta by A cos theta is equal to MP by OM, A and A cancels, so tan theta is equal to AY by AX. Look, this is the value of tan theta, because I told you before also, a vector is incomplete without its direction. It shows the direction of the vector. अगर मुझसे कहा जाए कि ए वेक्टर का डायरेक्शन क्या होगा, तो मैं कहूंगा कि ये tan थीटा एंगल पर अगर ये इंक्लाइंड है विथ रिस्पेक्ट टू एक्स एक्सिस, तो tan थीटा शुड बी इक्वल टू AY बाई AX. ये इसका डायरेक्शन शो कर रहा है, और इसका मैग्नीट्यूड कौन शो कर रहा है? ये A is equal to root AX square plus AY square. Simple Pythagoras theorem. All the things we got. Resolution. This is called resolution of vectors. Resolution means these parts are called the resolved parts or components. The vector has been broken into its parts. Understood? So this is regarding the resolution of vectors in two dimensions. Right? Obviously, in our syllabus there is the resolution of the vectors in 3 dimensions also, but try to understand first these things properly. So I hope, dear students, that you have understood it very carefully, properly. So now in the next lecture I want to do it in a very brief way, that if a vector is specified in 3 dimensions, then what will happen? Agreed? Alright?